In this lesson, we're going to be looking at exponents as integers. This should be a review for a lot of you, but let's just quickly talk about integers. So we know there are three types of integers. We have negative, 0, and positive integers. An example of each of these as a exponent, we could say as a negative 3 raised to the power of negative 2, maybe 1/2 raised to 0, and positive would just be a positive integer. Also, let's talk about the word exponents. So there are three words we can use to say exponent. The first one is exponent. The second word is power. And the third word is index. All of these mean the same thing, so you could say any word you wanted for the exponent. So let's jump right into it. Let's look at 6 raised to the power of 3. Well, that just means 6 times 6 times 6, which equals 216. Easy enough. Let's look at a different type of example. What if we have a negative base? So negative 3 raised to the power of 4. Well, we do the same thing. Negative 3 times negative 3 times negative 3 times negative 3. If we work from left to right and multiply these all out, we end up with an answer of positive 81. Now, I want to show you a different scenario with a negative base. I'll use orange for this one. So if we take the parentheses off of the base, it will give us a different answer. Basically what this is saying is take the opposite. So if we work this out, we still have 3 raised to the power of 4. So we're just going to do it like this. We know 3 times 3 times 3 times 3 is 81 from our other example here. But now we have to take the opposite. Take the opposite. So we end up with negative 81. So negative 3 in brackets and just negative 3 when raised to an exponent would be two different types of answers. So now let's look at 0 as an exponent. Well, the thing about 0 as an exponent is no matter what your base is, your answer will always be 1. Every time. So why is that the case? Well, let's remember our laws of exponents. So for us to get an exponent that equals 0, we're basically dividing two bases. So let's say 5 to the power of 2 divided by 5 to the power of 2. Well, when we're dividing bases that are the same, we can just subtract the exponents. So this would be 2 minus 2, which equals 5 to the power of 0. So why does this equal 1? Well, let's look back at our original example here. If we work this out, we end up with 25 divided by 25. Well, we know that equals 1. So it doesn't matter what base you have. If you raise it to the power of 0, it would be 1. Now, another exception to this rule is, I'll do this one in green, 0 raised to the 0. This does not have an answer. In math, we just say that it's undefined. We can't find an answer. So if you ever see 0 raised to the 0, there's not a solution. Undefined, no solution. So now let's look at negative exponents. So let's say we have 2 raised to the negative 4. So if we are using a positive exponent, we are multiplying 2 times 2 times 2 times 2. If we have a negative, we are basically just dividing. So this would be the same thing as 1 divided by 2 4 times. And we could put this in a fraction form. So that's the easiest way to do it. That's how I always work it out. If it's a negative exponent, we just put 1 over 2 to the power of 4. And we work it out the same way. So now we have 1 over 2 times 2 times 2 times 2. And all of that comes out to equal 16. So our solution would be 1 over 16. All right, well that is integer exponents. Like I said, that's probably a review for most people. This is just what we're just kind of brushing up on before we get into our logarithm unit. All right, well I hope you found this short video helpful. If you did, please leave me a like. If you have any questions, just leave them in the comments and I will try to answer them as quickly as possible. All right, well I'll see you next lesson.